The human race had millions of years to prepare for this moment. We could have built telescopes. We could have developed defense systems. But what did we do? TikTok trends and avocado toast. And now, it's too late. Wait a second. How did it come to this? Asteroids don't just fall from the sky. Okay, maybe they do. But to understand why we're now on the brink of impact, we need to rewind history. So hit the rewind button. Our journey begins 4.5 billion years ago when the solar system was still a chaotic mix of dust, gas, and rocks. In this celestial mess, not only did planets form, but also a lot of unwelcome guests. Asteroids, the leftover fragments. Earth has a rather tragic tradition. For billions of years, it has been pestered, struck, and sometimes outright pummeled by asteroids. 6 million years ago, a roughly 10-kilometer-wide asteroid struck the Yucatan Peninsula, leaving behind a crater over 150 kilometers in diameter. The energy released was equivalent to billions of Hiroshima bombs. The result? Goodbye, dinosaurs. A global firestorm followed by darkness, famine, and cold, so effective that 75% of all life was wiped out. You could say this asteroid put a definitive end to the dino era and paved the way for us. Thanks, Chicxulub. The Chicxulub impact was undoubtedly a cosmic knockout for the dinosaurs. But it wasn't the last asteroid to hit Earth. Over millions of years, our planet has taken smaller hits, some leaving spectacular craters like the Barringer crater in Arizona, created about 50,000 years ago by a 50-meter-wide meteorite. But not all impacts leave marks on the ground. Sometimes these intruders explode in the air. On February 15, 2013, an asteroid about 18 meters wide entered Earth's atmosphere at a speed of 18.6 kilometers per second and exploded at an altitude of approximately 23.3 kilometers above Chelyabinsk, Russia. The explosion released over 30 times the energy of the Hiroshima bomb, causing a shockwave that shattered windows over an area of 200 square kilometers and injured about 1,600 people. Asteroids are remnants from the solar system's formation, essentially crumbs left over from the great planetary baking. But why do these crumbs sometimes come dangerously close to us? Most asteroids live peacefully in the asteroid belt between Mars and Jupiter. However, Jupiter's gravity can occasionally knock some of these rocks off course, sending them on a journey, sometimes straight into our neighborhood. These cosmic wanderers are called near-Earth objects, or NEOs. They're asteroids or comets whose orbits bring them close to Earth, even cross Earth's orbit. We call them near-Earth asteroids. They often result from collisions in the asteroid belt, which release debris that gravitational interactions direct toward Earth. This is why scientists worldwide observe the sky, identifying and tracking these potentially hazardous objects. The goal? To develop early warning systems and, if necessary, defense measures. Because while the likelihood of a catastrophic impact is low, the consequences could be devastating. So, it's better to be prepared. The good news: the chances of an asteroid pulling the rug out from under us tomorrow are incredibly slim. The bad news: in the universe, incredibly slim doesn't mean impossible. And now, the moment you little apocalypse fans have all been waiting for, the big impact. What happens when the sky actually falls to Earth? The impact itself is an event of unimaginable destruction. An asteroid just 1 kilometer wide would trigger an explosion billions of times more powerful than any nuclear bomb ever detonated. The ground would vaporize under the heat, and a shockwave would rip across the Earth at supersonic speeds. The heat ignites forests and cities within hundreds of kilometers. Ash and smoke darken the skies. Buildings are destroyed across continents. If the impact occurs in the ocean, tsunamis form, inundating coastal regions worldwide. But the worst effects are often not immediate. Dust and debris rise into the atmosphere, blocking sunlight. What follows is a period of darkness, an asteroid winter that starves plants and animals. Food chains collapse, leading to mass extinction. Such scenarios are incredibly rare, but not impossible. The Chicxulub impact 66 million years ago reminds us of how fragile life on Earth truly is. While asteroids may be fascinating celestial objects, things get serious when they're on a collision course with Earth. So how can we defend ourselves against these cosmic projectiles? The first step in defense: know what's out there. Worldwide, telescopes and radar stations scan the skies for potentially hazardous objects. NASA has established the Planetary Defense Coordination Office to oversee the discovery, characterization, and tracking of near-Earth objects. If an asteroid were indeed on a collision course, we'd need to nudge it off its path. One method: the kinetic impactor. This involves slamming a spacecraft into the asteroid at high speed to alter its trajectory, just enough to miss Earth. NASA tested this technique with the Double Asteroid Redirection Test (DART) mission. In September 2022, DART successfully impacted the asteroid moon Dimorphos, altering its orbit, a milestone in planetary defense. Who would have thought the solution to asteroid problems would be a cosmic battering ram? Despite these advances, there are limits. Large asteroids, or those detected late, could be difficult to deflect. This is why ongoing research and development are crucial to strengthening our planetary defense. While movies like Armageddon and Deep Impact provide thrilling entertainment, we should remember that the real science behind planetary defense is far more complex and less dramatic, but no less fascinating. But unlike the dinosaurs, we have something they didn't: knowledge and technology. The question is, will we use them in time? If you enjoyed this video and want to learn more about the fascinating dangers and wonders of the universe, subscribe to this channel, share the video with friends and family, and let's make sure we're not the last generation to live on this planet.